Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos, is what I'm doing today. Let me close Slack here. Yes, that's what I'm doing today. Okay, so a couple things happened. I haven't streamed in 2 weeks. And last time I talked about some compression shiznit on C64. This time, another thing that happened is we released WaveSabre. That's an important detail. WaveSabre is our 64K synth. We've been working on it. I've been working on it since about 2012. And finally, it's out in the wild. I'm really excited about it. People seem to be really happy about that. Had really good, positive response. I don't know. It's just been a really good experience so far. And I think we kind of made the right decision because initially we were kind of holding that back until we could like document it more and do a music disc and all that stuff. And none of that stuff ever really materialized. So it kind of just made sense to finally just put everything out kind of as is. And then we'll kind of deal with stuff as stuff comes up. In any case, that's been awesome. If you guys want to try that, I'll link the repo in the chat. And then we also have a Slack channel, which I need to set up a bot so we can so people can just join by themselves instead of asking one of us for invites. But other than that, there's no reason why you can't just ask us and we'll let you in. I prefer you guys bug Hoffman about that, but that's only because I'm lazy. Anyway, we were talking in the development channel on Slack today, and I don't know. I haven't been working that much on the synth for a long time, just because we haven't really had a lot of issues to solve lately as people have been downloading it, of course. We have some compatibility issues to look into with making it work with latest Visual Studio, because we still use Visual Studio 2013, and there hasn't really been a compelling reason for us to upgrade. And that's just how it is. But I do want to support that stuff and set all that up. However, I'm kind of lazy. And what made me a lot more excited was talking about maybe multi-threading stuff, which is something I hadn't thought about in a while. And I was originally thinking that, okay, we can actually just do 2 render threads, and the converter for our synth could statically kind of decide which devices would be rendered on which thread or which tracks would be rendered on which thread, and then kind of merge that. And I still don't think that's a bad approach because the runtime becomes really simple for that. But when I was thinking about it, I realized that actually a fully dynamic approach would probably not be that difficult, where we're actually tracking dependencies at runtime. And yeah, I think we'll get a much better result from that. So I was thinking that we would do that with devices. Let me do some paint here just to finish giving you guys context. And then I'll show you what I did this afternoon and what we'll be working on later today. Before that, actually, I'll say hi to people in the chat. Alkama, how's it going? CBDT. Yeah, this should be really interesting. I'm guessing we'll get good stuff out of this, but I guess we'll have to see. It looks like there's a lot of potential for this to actually help, so I'm excited about that. Zokwar, Drew 2. Hells yeah, this guy knows how to party. Mr. Tove, hedgehogs are really cute. You bet they are. And Mad Moose. Definitely not rewriting in Rust. Oh, I'm not that worried about it, Drew, too, because we can, there seems to be a community kind of forming around this synth as well. So I'm not too worried about, supporting future versions also, because we can kind of cross that bridge when we come to it. I mean, philosophically, this is a tool that we make for ourselves, and that's always going to be what this is primarily. But of course, opening it up to the community allows other people to take advantage of the tech and contribute and make it easier for themselves to digest and use as well. So, because I could just as well, I could very well just be here's the synth, use VS 2013, and that's it. And to be honest, I think that's fine. But I kind of want to do a little more, but not too much more because I'm lazy. And we've got our own intros and stuff to do. And again, the primary purpose of WaveSabre is to support that. So we'll see what happens. But there's a lot of things that people brought up. Gopher of Alcatraz has brought up a lot of really cool optimization stuff that I want to look into. Drew 2 is mentioning CMake. Yeah, we're totally considering that. CMake and Mason is another one we might do. We already use Premake to generate the projects for the individual plugins, so we might as well just go all out on that and generate all the project files, at least for different versions of Visual Studio. But there's a bit more things too with different Visual Studio versions, especially when we're linking with no default libs, because it seems the MSV CRT ABIs have changed and we have to shim in some stuff, but we'll figure that out too. Yes, Salkama, that's actually awesome that you did that. I totally forgot that you were using CMake there, so I'm really glad you reminded me, because I will totally look into that as well. Anyway, just want to talk a little bit about what we're working with here, because what ended up coming up is, I already said this, didn't I? But this multi-threading thing. So when we're looking at a song in WaveSabre, we have these different tracks, and this is organized the same way in the replayer. We have these different tracks, and then tracks have several devices that run on those tracks. And essentially what happens is there's this top level code that says, give me 100 samples, for example. And what this will do is this will go through all the tracks and have each of those tracks render 100 samples. And the way it does that is it renders 100. This one renders 100 samples and then inputs that to this, and then that processes 100 samples over and over again. So each one of these devices on a given track depends on the one previous. And then if there's any inputs to a particular track, because a lot of these like group tracks I think are consolidated so that these are individual tracks, then the group track is another track that they all feed into. So like if you have other tracks feeding into this track, then the first plugin needs to depend on the outputs of those, but then the other one will just depend on that plugin or that device. The point I'm trying to make here is that we have this kind of almost hierarchical structure that forms here, where we have essentially the master track. I'm going to draw a little crown here. He's a king. And then all the other tracks that might feed into that. This kind of depends on that, on the other tracks. And most of the time you have all these tracks are in parallel and they don't really depend on each other, but sometimes they will. Sometimes, for example, if this is a kick drum, we might use that for sidechain. And so like another one of these might depend on that too. But we can always flatten this. We can always, like, sometimes there's loops, but we just say we don't care about that case. And if you have like the size of your buffer delay between outputs of one track and the inputs of another when you have loops in this graph, then that's your own problem, and we just don't care about that. But essentially what we do is in the converter, we go through, and so let's say this is A. Actually, we'll do it this way, just to enumerate them in some order. A, B, C, D, E. So what we do in the converter is we do a depth first search through all these. So A has a dependency on B, has a dependency on C, has a dependency on D, has a dependency on E, and then there's A. Silent ST, thanks for the follow. And then all these, like again, B has no dependencies, C has no dependencies, D has no dependencies, E has a dependency on B, but B's already in our list, so we're good. So this is essentially the evaluation order of the tracks. So if we evaluate them in this order, then every track, when it gets evaluated, all of its inputs will have also been evaluated. So this is what we do in the converter. We order all the tracks, so we don't even have to worry about that. We just evaluate them in order. However, what I'm thinking, and we can go another level and work on this with the devices too, which I want to do eventually. But what I'm thinking, first of all, is let's actually just store this dependency structure explicitly. And then what we'll do is have a pool of however many threads, which it can be user defined. So let's say like 2 or 3 worker threads. And what we're going to do is instead of rendering all these in order, we'll just dispatch all of them onto a big queue. And then the 2 or 3 worker threads are going to sit there and start pulling work off the queue. So like maybe in this particular graph, we could have thread 1 and thread 2 and thread 3 all working on these because there's no dependencies here. This one can't start. So even if we had 4 threads, we would actually stall here because E depends on B. But then let's say this finishes and then thread 1 can start working on this. And then this finishes and then this finishes and then let's say thread 3 picked this up. So we just have 1 and 3 working on this. So ideally, there should be enough tracks that don't depend on other tracks that can run and sort of fill in more space. Because the issue here is that if we render all these serially like we're doing now, we spend the cost of all those at once. But in the scenario I just described, we might be able to pay for the cost of B plus the cost of C plus the cost of D all kind of at the same time. And then when all of that's done, we can pay the cost for E and then the cost for A. And altogether, you can see visually here, this right here is how much time we save, and that should help. I think this is a really good way to tackle performance here. Like there's a lot of lower level stuff that we can optimize as well. And there's so many reasons to both do that and not do that. For example, it's a bit late to just introduce SIMD at a really fundamental level on a lot of the old synths, which would help for like stereo processing. Like a lot of our filter code could be basically written the same way. Whereas right now we run 2 filters, one for left and one for right. And we could just as well have done that with SIMD vectors, but we didn't a long time ago, and it's a bit hard to kind of port everything now, and it's not that motivating either because we want all of our devices to work the same way. So this would at least allow us to, I guess, solve a lot of those potential performance issues on a very general level. And because of the architecture of the synth, devices will never they're designed to be able to execute by whatever, whenever. They don't really depend on each other at all, other than, of course, their inputs. But that's just part of the part of their API that they take in a buffer and output to a buffer. Other than that, they don't really care. So this should all just work. And then a device itself, if we do all this right, it shouldn't matter that the code itself is actually executing on different threads. So that's what I'm thinking. Eventually, we can take this a step further. So let's say like track B had 3 devices on it. This itself just forms a different subgraph. So if we ignored tracks altogether, we would just have this dependency chain. And then E, instead of depending on B, it would actually depend on the last device here. So I know I'm making a mess here, but like in that way, we don't even necessarily need the track structure. We kind of do because the tracks also have like volume. And so then I was thinking we could put another stage here. But I think for the first version of this, let's just see what we can do if we parallelize on a track level, on a per track level. So what I've done this afternoon after I got home is I just started seeing how far we could get with this. And in particular, I've gone in the synth here. My font is going to be real small for the time being. Just crank this up a little. So what I did is I went in our song renderer thing and I just hacked some event collection here. Yeah, it's a dependency bush now. Exactly. So what I did is I made this trace event thing here. And so we have the name of the event, category, and PH, TS, PID, TID, which is like process ID, thread ID. Don't think those are used right now. The thread ID will be. And then I have a track ID as well. TS is timestamp. I don't remember what PH is. Anyway, we're just going to collect a bunch of those events. Right now, we just make this big array of them. And then also there's performance counter stuff so that when we render samples here, I make event when we start rendering a track and event where we end rendering a track. And if these names of these look familiar, it's because they should. At the end of this, I dump this to a big JSON file. JSON, however you like to say that, which looks something like this. The real one's a lot bigger. And so let's run this. And I also took this song is our Trash Panda song, and I just took a small clip of it. So our converter actually respects the loop points of the track that we're reading. So if I just make this the loop point, for example, it'll only render that. So I have this render a wave, just to that small portion of the song, so it doesn't take that long. And then this renders that out, and then it renders this trace.json file, which is somewhere. It's actually not that big. I'll just open it. So this is the real one. All these things. And then what we can do is we can open this Chrome tracing thing here and load in the trace. And this is really nice because then we're able to, if I zoom in a bunch, actually see the individual events here. So here we can see different tracks, and what we want to see here, which is what we do see, is that a lot of these take up like different amounts of time. And this is really good. I'm really happy with this. And we see how long the whole thing takes. We see when these start and ends, and we can also see that this is entirely serial. There's zero overlap here, which is what we'd expect. I think what I'll do here also there's some gaps here. That's not terribly important. Because it's not rendering 100% of the time that the program runs. So that doesn't really matter. Of course, there's like 50 tracks here, and it kind of sucks to see them all in order like this. One thing I want to do also here is I want to add events for when it starts and when it ends, like rendering a whole, I guess I could call it frame. Essentially when this WaveWriter's asking the song renderer. So again, just a little architecture here. This is the top level player test, and we have it in this write wave mode, and so it creates a WaveWriter. The WaveWriter contains a song renderer, and essentially that's all it does. You tell it to write, it opens a file. It writes the song in, I think, like 200. Is that this? No, that's something else. Step size, which is 100 times however many channels there. So essentially 100 samples at a time until it's done rendering. So I use the wave renderer just because it's a little easier to just have it render all at once than to like run the real-time renderer, which only renders when it needs to. So this just should be easier to look at in the trace. But essentially, whenever this song renderer is told to render samples, I also want to create events for that. So I'm going to do that really quick. And then we already have a setup where we can very clearly see essentially how long this normally takes, and we should be able to see patterns in the individual tracks themselves. And then we can work on actually parallelizing this, which I don't think will actually be that difficult. We may even finish that today, but don't get your hopes up because there's probably issues, but we'll see. So yeah, I don't know why I got really jazzed on this today, but I totally did. So hopefully we'll make some good progress. Anyway, let's do this. Int render samples calls. I'm totally just hacking this in here, and I'll probably just stuff this on a branch, get rid of it later. But what we want to do is this. Yeah, totally. I'll comment. I actually don't think it'll be that difficult. I have an idea of how I want the dependency structures to look, and I think we'll basically just be using critical sections. There really isn't much here that we're threading. We'll see. Anyway, so I'm just going to copy this stuff. Even put it out here just to make sure we get the stuff. So I'll copy this whole thing. And I think I'm going to do this too. I think that's the syntax. I don't do C++ enough to remember. And we'll do this, and then we'll just add a type. This type is a keyword in C++, isn't it? Or not? Good enough. Flying Guess, thanks for the sub. Appreciate it. Yeah, so here we'll do type. Okay, song render trace event type render samples. Most of this is going to be the same, except the track ID. We're going to use something else for this other thing. I'm being really lame here with the way I'm doing this, but I don't care. Because instead of running a track like that. Okay, and then the song renderer. I do this. Samples. It's going to do the opposite one here. That. And then we're going to do the same thing at the end. And that. Good. Oh, that's awesome, Drew, too. I feel like we talked about the fact that you took a break from streaming, but I didn't remember. That's great that you started again. Yeah, more vectrex. Let's try this. And really? Oh, that's why. That's awesome. I'm glad he did. I think Per Vonsen also just started streaming again, which is really cool. So let's open up Chrome again, and I think I need to reload this. Nice. So this is cool, because now we can see here, one of these was like a render samples call, and it consisted of all these tracks running serially. So a lot of these take 4 milliseconds, 2 milliseconds. Oops. I don't know why that just went gray. I really don't know how to use this viewer very well. It shouldn't matter too much. The point is that we should be able to look at a lot of this stuff. So around 2 for a lot of these. Some are a lot longer. There's some time between some of these sometimes. I think that's for the file I/O. But this is gorgeous. This is exactly what we want to see. Oh, that's why, because I clicked there. Good to know. And then yeah, these different processes, like we could separate that in the threads. I'm actually gonna use the thread ID to separate which thread all this stuff is rendering on, but it is all the same process. It doesn't really matter. And as you can see, I just did like 1, 2, 3, 4, 5, 6, 7, 8, so it doesn't really matter. Thanks for the host, Drew, too. Anyway, this is the starting point that I wanted. And in fact, I'm probably gonna push this to a branch. I'm just doing this on the public repo because why not? And there shouldn't be too much diffs here. Yeah, there's the song itself changed. That doesn't really matter too much. Kind of annoying that this is in the repo, but it just makes it easier for people to download and go, so we leave it in there. Then there's just the stuff to grab the events and nothing else. Good. Actually, I should be on a branch first. Yeah. Good enough for now. And then we'll actually work on threading this already. That was quick. Now I think I think this isn't going to be terribly difficult because while we don't necessarily have the track dependencies explicitly, I think we actually kind of do. So we go through the number of tracks and we run the track. And I think here, the track will process its MIDI events. And we could do that like for all the tracks just in one go, because that's probably easier before we dispatch all the rendering. And we could also do that with automations. No. I just realized I hit a big snag already. But I don't think it matters because we're parallelizing at the track level. So I think we actually avoid what I'm thinking of. Okay, never mind. I think we're okay. Anyway, there's this num receives. So each track knows how many tracks are going to feed into it. And with this receive information here, the receive is the sending track index, and then which channel we're going to receive that on and the volume it should be mixed at. So through this list of receives, especially with the track indices here, we should be able to check our dependencies that way. And I think that's all we have to do. And then each track is just going to do its thing altogether. This is actually great. This will work out really well, I think. No worries, Stuart, too. Happy to send some folks your way. Always happy to support another emulator stream. But yeah, so I think, I mean, I might have to make this public because I think this is on a track. And I'm just going to do this for now because I'm just going to hack it to make it work. We can clean it up after. And then we have num receives, and the type at least available to the parent, which I think we might have had anyway in C++. I really don't remember. I don't remember those kind of access rules for nested classes, but I think this is what we need to do. Okay, so then what I'm thinking is that there's always a flat list of tracks. And what we can do is we can set up, I think the easiest way to do this is set up just a flat list of booleans for which ones have been processed. Maybe boolean is actually wrong because I think they need to be in 3 states where we have essentially waiting and then whether it's being worked on and whether or not it's done per track. So yeah, I'm going to do this. Enum class render state. And so idle maybe is the right term. I'll probably play with these names back and forth a lot. We're going to have idle, and then we're going to have rendering, and then finished. And I think that's all we need for that. So essentially we would have a flat list of these render states. And when we're going to render, the song renderer is initially going to set all of those to idle. And then the render threads, what they're going to do is if they're free, they're going to look in this list. And then as often as they can, and every time they look at it, they look for a track that's idle. And that where all that track's dependencies are finished. I think that's the only condition we need to look for. And it's just going to keep... Yeah, comma, why? That's great. And then when it does that, it's going to set it to rendering and then render it. And then when it's done, it's going to set it to finish and look for another one. And I think that's all we need to do. And then the main sort of dispatch thread is just going to set all these to idle and then wait until all of them are finished. And in particular, it only has to wait until the last one is finished, because that should definitely have receives for all the other ones. Again, it's all in dependency order, so that should actually work. This is cool. I think we have everything we need, actually. I am going to have to create the render threads and a couple other things, and that might be a little messy. But this might just work. So, okay, so where's our... We should have a tracks list here. There. So we can do render state states. Why is this? Oh yeah, that makes sense. So we create the tracks. And I'm not really caring about the aesthetics of the code right now either. And then, actually, that's all we need to do, because we can leave those uninitialized. Actually, no, because we're going to dispatch the render thread right away, so we're going to need to set these to idle. Or, actually, we're going to set them to finished. And then here, states is new render state num tracks. Nice. So then totally all comment. I miss Emacs a lot of the time, actually. Not gonna lie. So I think I'm gonna actually make this font size a little smaller. I know that might make it hard for you guys to read, but it just makes it a lot more comfortable for me. We don't need this much of this on this side either. So all we really need to do here, yeah, because this takes the last track, takes its buffer. I think this is per thread. So we'll have to move that. That's okay. Figure out the number of samples. We'll need to put that somewhere where the render threads can find it. Derutu, that we can't use unique pointer or shared pointer because this is in a 64K synth. We can't rely on most of the C++ standard library. In fact, I think we can't rely on any of it. So we can't do that. And in fact, I might even get rid of new and delete because of some ABI changes. So we might even go full C style with this eventually. Otherwise, I totally agree with you. Yeah. So what we want to do is for I is 0, I is less than tracks. I'm basically ignoring the threading right now. We'll sort of add that later. Yeah, the only reason I even have a lot of even destructors and stuff is because, like, for the music disk, I think we want them. But I might even just do like a bump allocator for that stuff, and let the user deal with that. And I think we don't have any dynamic allocations during rendering anyway, except unless you change one of the parameters that affects an internal buffer size. So like if you change delay length or something on one, like the reverb, then that will cause a reallocation. And I think I might change that as well later, where I just always allocate the largest buffer size, and then we don't have any. And that's enticing. Anyway, this just needs to set states. I is render states finished. Actually, no, idle. So dispatch thread, render threads. And I think, yeah, and then dispatch thread. So this is essentially the loop. We basically want to do something like this. So here, that. You know, and technically, since we know this is running x86, we don't need to, this part won't need to use the critical section. We can just always read that value and we're fine. Because there's only ever going to be one writer to it, and we know it's going to write this one particular value. So we're actually okay there, threading wise. But here we want to be in a critical section because we don't want, between like the time we write the first state and the time we write the second state, for example, we don't want rendering to say like, oh, hey, all the dependencies for all the tracks after this first one are done. Because that's not the case. So this needs to be atomic, where we tell the threads how many samples to render and that all the states are idle. And then the render threads will do their thing. So on each thread, we want to do this part in the critical section. And so if states is not idle, we'll look at the next one. And we may want to try to optimize this loop a bit too, but we'll get to there. We'll get to that later. I have a feeling this is not going to cause us any problems. I don't think there's going to be that much contention on this. And this is going to be relatively fast anyway. So, because most of the time is going to be spent actually rendering, so I really don't think this will be an issue. So if it's not idle, then we're not going to render it anyway. And the only reason why we even differentiate between rendering and finished is so that we know when the dependencies are actually finished versus when they're being processed. And just idle doesn't give us that because, or just idle and finished doesn't give us that because we also need to mark that we're processing one so that we don't pick them up in this loop. So we need 3 states. So then if it's not idle, we continue, and then we need to loop through all of its dependencies. If that's also the wrong index here. index. So we're going to do this. So if any of these aren't finished, we're also going to continue, but we want to continue this loop. I don't remember how to do that in C++. We need to do it as a goto in that case. I'm just going to do that. And then here, we're going to do states. Next track index is, actually we'll break. Yeah, feel the pain. Feel the pain in my goto. And in this case, we need to, if next track index is less than num tracks, we're going to do states. Next track index is equal to render state rendering. And then we want to leave the critical section. So then we've kind of processed, we've sort of taken that out of the queue, if you can imagine it that way. And then here, we want to do this. Again, this is on the render thread. Then we're going to do this. And then finally, I'm going to render the stuff, and then here we do states. Finished. Whoops. And actually, one of the things I might want to do is have the render thread keep track of which track they just rendered, and have it set this inside it when it enters this critical section. Because here we enter critical section, and then we're going to process a bunch of stuff here. So we want to leave that, but then we're going to enter it again. And then immediately after, this is going to be in a loop that enters it again. So we're sort of creating extra contention there that we just shouldn't need. But we'll deal with that later. For now, I'm going to also do this. Again, this is next track index. We want this to be in the critical section because this trace event index can be clobbered, and we'll get bad trace events otherwise. So then this looks like this. We're looking pretty good. So we can even do this. And this is just if states I want to be careful of this though. And anytime we're doing this stuff, we're probably going to want to do some kind of sleep as well. So what's like 32 sleep minimum time? I don't know if we necessarily want to call sleep whenever we do this. I think we do, though. But maybe not. We'll have to see. We'll see what happens if we just don't do anything first. I could use RAI for guards on these critical sections, but I'm not going to do that initially, at least, just to get this to work. So I think we just have to dive in and do the threads now. And I don't think that ends up being very difficult, actually. In this real-time player, I already have, actually that's in direct sound render thread. I already have a lot of the stuff we need for this. So I think we're gonna need our critical section here. And again, I'm just gonna kind of make a mess here to get it to work. I don't really care. And then we'll do the threads. And the reason why I have this, I'll do this under threads. And the reason why I have this bool shutdown is so we can cleanly shut down the threads by very simply just signaling that they're going to do that. I think in this case, we can just hard kill the threads though. I don't think they'll allocate any memory. They shouldn't. So let's actually do that. In any case, we need render threads. And I'm going to do this too. And for now, I'm just going to hard code that number. Just to play around with that. And then render threads is new handle render threads. And then here, initialize critical section here. And then we're also going to want to create the threads and set their priority. I have like really high thread priority set for these real-time renders. And that's just fine. So we want to initialize the critical section first. Because the render threads are going to use that. Hey, Pyro. Number render threads, I++. No worries, Pyro. I think you'll get to see the most exciting parts here. So we'll do render threads I is this. This is also going to be render threads I. And the thread proc we'll get to. Now, before we move on, I do want to do this. And we actually want to delete the render threads right away. Just so that they're not accessing anything that we might already be deleting. So render threads, and here wait for single object. What else can we do? Just called terminate thread, I think. And then the exit code doesn't really matter. We're making a clean exit here, so that should be fine. And terminate all those, and I think this waits until it does that. It says it's dangerous. This should only be used in extreme cases. Which, that's actually fine. Yeah, we're good. I like this. Then we'll go ahead and do delete critical section with our critical section 2. We only need the one, so that's okay. And I think, why didn't it like that? Is it because I need to do a pointer here? Yes, it is. Great. And we just send this as the param here. Yeah, this is fabulous. So we're going to do this now. Where's my song render? Here. And we'll just stick this here. In fact, all of this is more or less what we want. Just do this. I'm going to do this here for now to make this easier. And this is going to be song render. And this will do song render is a song render. So we'll get that. Yeah, super portable player. Portability is something that we need a lot of work on in general. And that's not something I'm going to worry about today. But definitely something I want to do later. And I think we just do this. So the first thing we're going to do is run this on here. Get the song render. We do our flags. And then we do this. That's all we do. Now, a lot of the stuff needs to be qualified now, and that's to be expected. Not that important. Yeah, this end counter now is also not the stuff here. Looks a little different now. And then this start counter. I know full well that I'm making very ugly code right now. And that's totally okay. This should be out here. And this we'll get to. Because this num float samples we need to get from here. I'm just going to do this. And then when we do this, set that there. And that's how we'll dispatch the rendering. maybe here. How much you guys want to bet this actually works first try? I know I won't take that bet. But I actually don't think this is that dangerous either, to be honest. So we just do enter critical section and leave critical section when we need to do this. So go ahead and do this here. And here. Very important that we don't do it around this. And then we're going to leave the critical section here. Oh yeah, this is also wrong, so it's a render thread here, which is silly me. And yeah, we want to leave this here too. And then, hey, new school, we're going to enter the critical section here. And we're going to leave it here. And we're going to do the same thing here. And we need to do this in 2 places. We need to do it here, and we need to do it here. RAI would do this for us if we had a guard here. Keep that in mind. Okay. Oh, syntax error. Is it because of this? Probably. Good. I'm really nervous to see if this works. It didn't freeze. It produced a wave file that sounds okay. Guys, did this really just work? And that did seem faster, didn't it? I don't know if you guys noticed that, but to me it sure did. So like a lot of these are around 1.5 milliseconds with some outliers. If I load the trace again. Oh, guys. Oh, I feel like such a badass right now. This is beautiful. Absolutely beautiful. Yeah, critical sections are WinAPI feature that's essentially like a lightweight mutex. You can only use them in the same process, which is perfect for this use case. So they're a little lighter weight because they don't have to do anything between processes. Look at this, you guys. Look at this. This rules. So now these are like still around a millisecond. And I'm actually wondering if maybe we can't do a little better here. This seems really janky. Like this is just waiting for a long time. That seems weird. And it seems also that, oh yeah, we don't know which thread these are being picked up by. We need to add that to the trace too. Oh, I'm thrilled that this works so quickly. I did not expect that. So I think what we need to do is we need to get the thread ID. Actually, can I just get that from Windows? That's the easiest way to do it. I wanted to do like thread 1, 2, or 3, but it really doesn't matter. We can just use the actual thread ID. We can even get the proper process ID too. So this is really easy. Is it the thread ID first that I had here? Why did I not do this like years ago? This was so easy. I forgot what I was looking at. Oh yeah, this. Thread ID is the second one. Hopefully that's fast. I'm assuming it will be, to be honest. To get the current thread ID. If not, it's very easy to amortize this. And yes, get current process ID works. Went out on a limb there. Run this again. Oh, that's so rad. Hey, my love. This is so cool. Yeah, so now we can see this render samples is the dispatch thread, and then we can see the tracks distributed on the other threads. This is gorgeous. Yeah, here we're getting like 800 milliseconds instead of like 1.5. Was I saying milliseconds before? Also, I'm pretty sure this should be microseconds. Because 100 samples is not that many. I'm pretty sure that I report this in microseconds at least. Let's see here. If I go way to the beginning. This first event here, for example, 1.335 milliseconds. So that's actually correct. These are microseconds. So now, yeah, we're seeing a lot of these are like 3/4 of a millisecond, whereas before they were like 1.5, which means we basically got double the performance for very little code. And this generalizes to any song, which is awesome. And the other thing, yeah, it does say 8 microseconds to the top. That's a good point. Or when we zoom in enough, I guess. This is so cool. Now, I guess the returns here are going to diminish pretty quick because like these are probably tracks that had a lot of other dependencies. Another thing that I might worry about a little here is I'm going to do something here. We might be using a lot of CPU. In fact, why aren't we hearing anything now? That seems wrong. Yeah, we froze here in the real-time player. That's not good. And I don't actually know why. But now we're really doing threading. Now we're threading with power. So we're not frozen, so something's just waiting on something, is what that means. Can I pause this? I can run this in the debugger at least. It worked in the debugger. That's not good. That's literally the worst. That it worked when it ran in the debugger and it didn't otherwise. Oh, that's just funny because this is how threading works. Okay. Question is how to debug this. That's funny. That's funny. Yeah, debugging is going to take 2 weeks, and we're still not going to know if we actually solved the original issue. It's just going to appear to work. The first thing I'm doing is I'm just thinking about like what could make this freeze, and actually the fact that we're not sleeping might be what it is. I wouldn't necessarily expect that actually, because I would imagine the different threads get good enough time slices, but maybe because all of these threads have high priority, maybe that's a problem. So I'm just gonna do this. Put some sleeps in here. And if we see that this actually helps, then we might be in for some fun. Didn't help. Yeah, just throwing around some breakpoints is probably helpful. For example, we know this is going to happen, and we know eventually this is going to sit here and wait. This, and we also know that we want this to be rendering tracks, and it probably isn't. We're probably never getting... Where does it do that? Finds a track, renders it here. And we know all the states are finished when we start. We also know all the threads are going to be looking at all the possible ones that they can render. And whenever they find one, they're always setting the state to rendering inside that critical section. Now again, the shitty thing here is that it works in the debugger. And we see that we alternate between these as we should on different threads. Then why doesn't it work outside the debugger? So I actually find this really weird that this doesn't work. I mean, typically that's the case with threading when it doesn't work. But it's weird because I don't see how it couldn't. So let's go over our invariants here. So we have, or at least the things that we're assuming. So we know that when render samples is called, we know render samples is only ever going to be called like this is not going to be reentrant. We can test that actually. So the threading setup we end up with is that we have a main thread, a direct sound thread that's just pulling samples out of this, and then 3 render threads on top of that that are actually rendering samples after this does the dispatch. When this enters here, and this shouldn't be reentrant, and it shouldn't be reentering either, because the direct sound thread is only ever going to call this in this one main loop here. And that should be fine. So when it calls this, again, we can test for that, but that should be fine. And then oh, this is actually one thing we need to be doing. We need to be making these events here in this critical section. No, we don't. We don't actually, because none of the threads are going to be actually rendering anything at this point. So we know, what do we know? We know none of the threads are rendering here. They're running, but they're not rendering anything. We really need that. Then we enter the critical section. So we essentially acquire the mutex. We're going to set everything to idle and set num float samples. And that's going to dispatch rendering. So then we leave the critical section, and then rendering is happening. At this point, we're going to have this loop. So the threads are rendering now. And we're going to loop until we see that the last state is finished. And we always do that within this critical section. Again, I actually don't think we need it here. I think we're okay there. And then we're just going to go until the last one is finished. And then again, nothing will be rendering after that until we enter this again and do this dispatch. Because the condition for these to render is that it's always looking for tracks that are idle. So this enters the critical section to go through this list, and only one of them will go through this list at a time. Presumably the other ones are going to be rendering or doing nothing, just going through the list all the time. And it's okay if there's a fair amount of contention here because they'll eventually get there. So this enters the critical section, tries to find... Actually, wait a minute. Yeah, here's the leave here. I actually don't think I did this right. Because we need to enter the critical section here, find a free track. And then if there's a free track, we actually want to leave the critical section, process the track, and then enter the critical section again. I know this is getting kind of hard to follow, but I think this is actually the correct logic, because we really don't want to be holding that while we're rendering this. And that might actually have something to do. We might see better performance here. So that still doesn't work. It's very strange. I wonder too if it's the thread priorities that I set. I'm really not sure. We might have to do some printing from the different threads. See if that helps. In fact, that's actually what I'm going to do next. Is here. SDIO, isn't it? I think. Yeah, I should do the line break, thanks. Okay. And now it's working. It's really slow, but I'm guessing that's just because of the printing. And here we see that it was actually rendering all the tracks. So something was different between when we were rendering that and when we weren't. And I don't know what that is. I'm wondering, though, if it is actually our thread priority here. That's breaking us here. So that again shows that, like, I think the logic here is correct. Yet somehow These threads aren't rendering anything. Let's just try this. See if that even makes a difference. And it doesn't, which is annoying as hell. I do really quick though, I actually want to try this again where it renders this just to see if maybe our graphs look a little different, or the trace. This clearly works, and works well. I don't expect this to look much different. This does have the sleeps in it now, so maybe we'll see some effect there. In fact, that's probably why we see more space in between these. And altogether, things look a little slower. So sleeping didn't help. And I think that's what made all these gaps in here. In fact, I'll remove those and see if that is, in fact, why we're seeing that. Maybe this one wants to sleep to avoid some contention there. Let's try this. Just so that the one that's sitting there just waiting for all the threads to be done shouldn't create that much additional contention for the other ones. Because the other ones should only be looking through that when they're looking for additional work to do. And they should be able to do that pretty heavily. And there it looks like it removed a lot of the gaps, which is what I wanted. This is so cool. I love this. Except it doesn't work with the other renderer. And I really don't know why. And it did when we were printing stuff. Classic. Hey, Daniel Colin. I think this is more or less the same as the condition variable. I mean, otherwise we would set like render dispatch, but I mean, this is kind of the condition that we're waiting for. So I think we kind of are. And I also really don't think we need this critical section here if we're just reading this and we know one of the other threads is going to write it. So I actually think this is actually what we want, which would have even less contention. And that doesn't work. That's so surprising to me. Oh, that might be why. Chugging through that. Ruh-roh. Why didn't those events finish now? That's not good. He did not finish. Oh, you know why I think that is actually? I think that's because this state finished is going to be set before it's this. This is why. This state finish could be set before it creates this, and we weren't entering the critical section to create that event. So I could have put critical section around this, and that also would have fixed it. That's probably a better idea. But I think this is actually good enough. Yeah, I think this is what we want here. That should fix our traces. Yeah. Now we got good traces again. These are looking pretty. A lot of idle time here. See that? That's crazy. Not always. This is kind of funny. This thread picked this up. Also, I think I actually want to do a quick reformulation here where I want to do like this. We're going to do this part here. Did I do that right? No, I copied the wrong thing there. Or did I? Yeah, it's this part that I wanted. Now I see what I did. I want this to happen. And then I want this to happen here. Yeah. This makes sense to me. So essentially what I'm doing here is we enter the critical section, and then if we had been rendering a track, we're going to create the end event and finish. And then we're going to not enter and leave the critical section because immediately we want to search for another thing that we can render. So this should actually reduce contention on that critical section too. This is twice now, so get rid of that. Probably by a minuscule amount, but that should actually be correct. Oh, these are pretty. This is what we want to see, where it's just like all full. I don't know why some of these have some of this extra idle time. Maybe it is because we're doing that sleep. Shouldn't be, though. This is crazy. That's a lot of time idle. No idea why that is. I like our loop at least. We're using WinAPI all over the place in this Pyro. It'd be nice to make this more portable later, but for now, we're not doing that. And yeah, this runs in a 64K. I mean, this still looks good. Yet why won't it work in the real-time case? Like, I just have no idea, and I have no idea what we're missing to make it do that. Let's just, for the sake of trying something here, let's not set thread priorities. I think those are the only two places I ever set this. We're getting nothing. Why is that? It's so frustrating too that this, if I print anything, it works. And if I run it in the debugger, it works. Although, we did get crazy sound just now when I ran that in the debugger, which might be buffer underruns, but I expect it's actually just that I did something wrong here. And that might be a clue. And so now sometimes it's not working in the debugger. That's great. Although that might also be our thread priorities. It's like if this wouldn't set this often enough, I'm not sure. Yeah, I don't think we do either. So what I can say, right, for now at least, is that this doesn't change anything when I'm running it in the debugger at least. So I'm actually going to remove that just to, that should help. At least it should remove variables. Yeah, move away. I did go over that, but it wasn't that terribly complicated. It was just that I was collecting, I can just show the code here. I was just collecting trace events into this array and then just dumping them at the end. Doing it pretty manually here. And then, yeah, using query performance counter and query performance frequency to get the actual elapsed time. So just as a question here, is it more stable when I do this? No, it sounds like threads are stomping all over each other, actually, when I'm listening to it in debug. It seemed to work like the first time, and it seemed like we were at least producing executables, at least producing the right sound when we were running it like this. So, but at least that's a clue that something is not correct here. I totally wish I would have written this in Rust. At the same time, though, that would have required like MPSC or something, which I can't use in a 64K, so I at least would have had to write these primitives there. And in that sense, I could basically do the same thing using RII. Yeah, so this is producing incorrect audio, which is actually good, just because it tells me that something is logically wrong. Which is what I want to see. Not just that it works sometimes and doesn't other times. Now, I still think we do need to enter the critical section here because this is our dispatch. We shouldn't need to do this here, but I can do it to be pedantic. And the logic for doing this, I think, is correct. We're waiting until the last one is finished, because the last one is the one that we're always going to pull audio out of. And we know that because the tracks are in dependency order, this should be the only condition that we actually need to watch for. Because this won't render unless all the dependencies have been rendered, and we know that. And I think that's okay. And we also know, since none of the other ones are going to be rendering, that this code should be okay. And we're getting good traces either way, so like we know that stuff is okay. So let's look at this code again. We're going to enter the critical section because we're going to look for more work that we can do. And the first thing that we're going to do we're first going to look for more work. Or first we're going to just finish we're going to mark the state of the track that we just processed, if any, as finished. And then we're going to look for new work. So we set this to 0, and then while it's listed on tracks, we increment that. If for any of these the state is idle or is not idle, so if it's either rendering or finished, we're going to skip it. And then if it is idle, we're going to look through its receives, which are all the tracks that it depends on. And like, for example, the master track should always have dependencies. We never have inputs to a track that's not expressed as these receives. So for all of those, if any of those is not finished, we're also going to continue. So our invariants are, or our assumptions here are, we have a track that's idle and all of its receives point to tracks that are finished. And only under those circumstances can we actually render. In that case, we'll get here, and then we'll break the loop, and then this will be our track index. Otherwise, we'll have continued, which is what we're doing here. So I think that's okay. So then if we have a track to render, wait a minute. What am I doing here? This is bad. This is probably what I broke. So then if we have a track to render, we want to set the state to, this is the logic we want. We're going to set the state to rendering, and then we're going to create an event about it, and then we're going to leave the critical section. And then again, if we have that, we're going to actually render it. Because we set it to rendering while we still have that mutex acquired, or the critical section acquired, and then we're going to actually render it separately. And then when that's done, we're going to set its state to finished while we have the critical section acquired. It still doesn't work in the real-time player without debug. We can try it with debug. And then I suspect we'll hear the right thing if it works. But it doesn't work. What the hell? Then the next thing I'm going to do is try this again, where we're just rendering the wave. This chugs right along, so I don't know what's happening here. And that sounds correct. So that produced a valid wave file. So then what is happening wrong in this case? I'm just going to run this again. And let's set some breakpoints now. Particularly, we'll go, wrong code here. We'll go and we'll set a breakpoint for our exit condition here. And again, I still don't think we actually need the critical sections here. I think we might just be creating additional contention there. But in any case, this is what we want to see. And I'm also going to do that here, where we're actually going to render one of the tracks. That is not where I wanted that. I wanted that after the break, so this is actually fine for that. So we are rendering something. In fact, do we have locals? Not really. Can I do a watch on next track index, or can I not? No, I can't, because this is in release. So, oh, it did actually look like we got here. And can we see anything? So, okay, this is rendering 200 samples at a time. Still doing that. I think that's just what it does. So this is looking good here. Okay, now it's working in the debugger again. Now it's not. So sometimes it does, sometimes it doesn't. Which is very fun. And what's the difference? So let's find a case where it's not working. And then I'll try to add breakpoints. So we'll add one here. We never get there. Add one here. Okay, so something's locked up here. Now I'm guessing we are stuck in this loop somehow. No, we got nothing. Where could this be stuck? That's my question. Can I pause? Where were we? That doesn't look right at all. Why would we be there? Breaking the debugger didn't help either. I'll try that again though. It put us in the destructor, which is not where we should have been. Okay, so this is on the main thread. We're just waiting for escape to be pressed. And here it's destroying the player. Why is it doing that? Why do we keep getting these breakpoints in these destructors? Oh, I actually think I know why we got those breakpoints there. Because we probably waited so long, because the song doesn't play for very long, it probably waited so long that it was actually destroying that at that point. Yeah, maybe I can disable optimizations for this player code is actually where it is. That's a good tip. So let's try that. We'll go in here, and I think it's in here. Optimization. We'll do disabled. Hopefully, this doesn't just work. It does just work. No, now it doesn't, which is good. So it works sometimes, which at least matches what we had without optimizations. So let's do, this is actually good. Let's see if we can get a case again. Doesn't work. Let's see where we pause. That's again in the main thread. That doesn't help us. And here it's shutting things down. Because we waited too long again. It's taking forever to shut this down too, which is kind of strange. But this, I think, is it's probably, it says it was here, but it might just be waiting for the render thread to shut down, in which case it might have been stuck somewhere, actually rendering, which is more what I would have expected. But again, I don't know how this can lock up like this. Because even if we, like coming into this rendering function here, render samples, we're assuming that none of the render threads are actually rendering, because we're assuming that the render states for all these is finished. And we set that here. Like before we even created those threads. Yeah, I forgot you can check the other threads when you pause like that, can't you? I totally forgot you can do that. Pause somewhere. Did that just put me somewhere? Yeah, so here we're on the main thread. How do I see my other threads? Been way too long since I used Visual Studio. Bug Windows threads, thank you. Beauty. Hopefully, this tells us something. How is that not in my code? Is that just that it's idle and waiting or something? That's just so strange. Yeah, thanks guys for walking me through this, by the way. It's been way too long since I did this. Let's pull this over here. Yeah, so it is an NTDLL here, which is strange. We expect this to be in player test. I wonder if the thread's crashed or something. And I wonder, hey Bamba, yes and no. I wonder if that might be because of this. Like if we're getting just a ridiculous amount of trace events, for example, when we're running in the release player. I don't suspect that would be it, but it might be. And then if we overrun something, all bets are off. And that's not it, unfortunately. It still doesn't work. Yeah, it should catch that, because if we're overrunning this buffer by a lot, then we should get a memory access violation somewhere, some page fault, and we don't. So just for a little sanity check here, I ran it and it worked this time. So if we look at our threads, here's our render threads, and these are looking great. These are actually, here we had one that's rendering. Here we had one that's going through and finding more work to do. And here we have another one that's going through and finding more work to do. That's fine. Yeah, Bamba. I don't remember how to enable exceptions. Isn't that in debug? Exceptions. I mean, I might as well just do all of them. At least the ones that make any sense. Okay, that worked. Okay, this didn't work. We didn't catch any exceptions. It's interesting, these threads just don't even seem to start or something. Let's try something else. Let's just try this. Like, do we even get to the thread proc? I would guess we do. Yet, whenever I pause, they're just an NTDLL, so... Okay, that's interesting. It only seemed to start one thread. Let's try this again. Nothing. Okay, this is weird. Now it's not doing anything. What the hell? Yeah, my Rust was showing. Well, I should have seen this coming. Yeah, I did have a bang there for a second. Whoops. So why does this matter? Even if we do something like this, just for some reason if that caused problems. Now it didn't print any of these. And now it did, and it works. The bang makes it a macro, and printf is a macro in Rust. That's all it is. Okay, so at least we saw a correlation, like this got here whenever it worked. And whenever it didn't, the song didn't play. So what could go wrong here? Let's try something here. If okay, so at least that didn't cause any problems. So create thread's not returning null here. I mean, why wouldn't these threads start? That's why I don't understand. I wouldn't think that, Daniel Collin, because it does work sometimes. So I just Googled a bit, and apparently people are using begin thread for this. That seems weird. But that really shouldn't matter. because I use create thread to create the rendering thread too. That shouldn't matter. And actually, I think this song renderer object might even be created on the main thread. So in the, I think it's the direct sound render thread that owns this actually. No, it's not actually. Or maybe it is. Don't think so. I think it's the real-time player that makes a new song renderer on the main thread. So those threads are actually being created on the main thread. And then this other code gets called on the, or then the song renderer is actually used on this other thread. That should be fine. Starting to get frustrated now. So I just want to see if this one always starts. I'm guessing it does. Or not. I do not understand this. There, it worked. Okay, so actually, one thing I notice here, it doesn't seem like we ever only get one of these started. It seems to be all or nothing. And there's a couple interesting things about that. Doesn't work here again. Now it's really unreliable. And I have no idea why. The creation code should get called. There's no reason why it wouldn't. That would be this. That's definitely called every time. Whoa, whoa, whoa. Why was that called that many times? Why did this happen again? We might have something here. Why does this happen twice? Oh, that's actually the case. That's actually true. The real-time player does actually create a song renderer here. And then it ends up building another one in the play function. I don't know why. I don't remember why I did that. But again, I feel like that shouldn't matter. We should have some threads spinning that are just doing nothing. But it shouldn't really matter. In fact, we can have less of them to see if that even makes a difference. But it doesn't. And now we're still not seeing the prints from these threads being started. I'm wondering, because I read here that the C runtime needs some per thread initialization. I'm waiting on specific threads, but I'm waiting on specific threads that should match up with the renderer that we're using. That's the weird thing. We're always waiting on the right threads. I'm guessing the reason why printf here it probably isn't working. It's probably because we're not initializing the C runtime on the thread. Maybe that's it actually. Well, no, because then why did this work in the first place? We always create the song renderer on the main thread. And the only thing that we've moved now, so here, render thread callback. That's because the real-time player here gets this callback, gets the song renderer, plays those. The only thing we've done is put this on a separate thread again, and that shouldn't be different than what we did for this direct sound thread. Yeah, I'm not thinking so either, Dinnercon, because I don't think that this would have changed that. Yeah, that's a good call. I can try that. At least that might help. And I guess we'll see that here. Oh. We saw it here, and then it worked. Works again. Works again. It didn't work. And again, we didn't see that. So somehow, sometimes these threads just aren't doing anything. That's the wrong line. And why the hell is that the case? I think I have 8 cores. And even now, I actually turn this, that's why we only saw that once, I turned this down to 1 other thread. So we should be running 3 threads here, in that case. The resource monitor that will tell me that? I think it's 4 cores and then hyperthreading. So I know that this thread definitely sleeps. Yeah, maybe it is this one that's sitting here spinning on this. This still sleeps 0, which should be enough to fix that if that's the case. Yet it's not. But then the other thing that's happening is these aren't sleeping. Actually, if we're going to do that, we should do something like this. Nothing changed. It's so strange. This is really fucking frustrating. Can we do anything that can wait for thread to start? And see if maybe that doesn't happen? So I'm seeing here that they're using like wait for single object. And then they're having the threads, I think, post an event. And they end up waiting for that. Process. They end up calling peak message, which shouldn't matter. But even then, I don't really understand why we would need to do that in this case. And I see a lot of code that just creates the thread and then that's fine. I mean, again, that's what we're doing for the direct sound thread. A lot of people still suggest to use create thread.ex. Or begin thread.ex. I mean, does that really matter? And that is part of... Isn't that like POSIX stuff? Even the example they use just does create thread. And that does wait for multiple objects for them to finish. But I still don't see why that would matter. We're not passing any creation flags. What about this thread ID parameter? Yeah, that's just going to return the ID of the thread, which we don't need. Stack size shouldn't matter. Attributes shouldn't matter. Stack size shouldn't matter. The parameter is correct. I gotta admit, I am stumped here. All the example code I'm seeing is doing what I'm doing. Yeah, I did see that there are more threads created. So for example, if I run this and there, it worked that time. Worked again. Just gonna do this until it doesn't work. Still working. Now it plays nice. That's so annoying. I mean, outside the debugger, of course, it doesn't work. Now I can't get it to not work in the debugger. Okay, there it doesn't work. So if I pause, we do see that there's different threads. Although, yeah, no, this is what we want to see, because I think we're still only spawning one render thread. So this is correct. And yet, yeah, we do get another thread, but it's an NTDLL. So it seems like it never gets to this thread proc. Which is again what we're seeing. So if I even just have a breakpoint here, yeah, we never hit that. So why? multi-thread doesn't call start routine. It should be dword when API. It should also be static, which obviously it's going to be. That should be all we need. And with the LP void L parameter. So we're good there. Oh, this is ridiculously frustrating. And there it happened. And we resume and the song plays. But sometimes this just doesn't happen. Now it's happening a lot, but that's also what we saw. So sometimes this just doesn't work. Many times it doesn't. Yeah, and we can see location is correct here again. Now, don't get me wrong. I do think it sucks that this direct sound player is creating additional song renderers when it shouldn't need to. For example, the WaveWriter doesn't do that. And I think the reason why it did that was so that this direct sound, no, the real-time player, I think it was called, does actually create multiple song renderers. And since song renderers always spawn render threads, we're going to end up with a bunch of extra threads here, but it shouldn't matter because we're still disposing them properly. So unless... And even then, if that was causing us problems, we should at least get to this thread proc running from one of those. So that shouldn't matter either. One second. Okay, so Dan Collins said if I just add a printf for you, I create the threads and then runs outside of VS, I should be able to see if that code gets called at all. But I'm pretty sure we saw that it did. I mean, I guess here is what you mean. Just run that a few times without debugger. And there, of course, it did. And it played. And I'll do it again. And it worked. I'll do this again a few more times. And what I want to see is happening every time now. And in fact, I'll even do this. Still happening. Okay, so there it said it created the render thread, and now it's not playing. Yet it printed that it did. So there's a case where this code here is being called, which makes sense. And we still never enter this thread procedure. Why? One of the things that I actually wonder about let's just say that this terminate threads thing, or terminate thread thing is fucky. And maybe when it creates that second song renderer and then calls terminate thread, maybe that breaks something and then doesn't allow us to run threads properly after. I don't at all suspect that this would make any sense, but maybe there's something to that. Now it's not running anything. It looks like it just crashes. What the fuck? Now we break on something. Oh, I know why. Because we never actually terminate those threads. And then they end up reading bad memory. I'm going to try just one more thing as like a Hail Mary. And whether or not this works, I'm going to leave. Actually, you know, because I was thinking that I could try somehow get around making this other song renderer. I think I can just do null pointer here to do that. And then nothing should crash. The reason it creates is so that these methods have something to call when we haven't necessarily made a song renderer. But this way it'll only ever create one of them. And maybe it is that terminate threads thing. And in that case, proper shutdown would fix this. I'm going to run this 10 times. And if it doesn't break in those 10 times, so that's 3, 4, 5, 6, 7, 8, 9, 10. And that all worked. So maybe there's something to this. And in that case, I'm going to do one more thing, which is that I'm going to do a proper shutdown for these threads. And for that, I'm going to take the same strategy I used here, which is this shutdown variable. And so the song renderer here gets bool shutdown. And then here, we say shutdown is false. We create all the threads. And then here what we do is we enter the critical section, set the shutdown, and then wait for the single objects. In fact, what we're actually going to do is wait for multiple objects. Do this here. And I think this is going to be the number, so num render threads, true, and then infinite. So we're going to wait forever for them all to leave, or to shut down, and then we're going to be done. And then what we want to do here is actually check this shutdown thing. I do that here in this case. So when we're here in this critical section, or while, I think I'll just copy this here. Bool is running is true. While is running. And then while we're in this critical section, we'll just do this. I think we enter and leave all the time here. Really doesn't matter. The easiest way to do this is this. If song render shutdown is running is false, and then the next time this condition is checked, we'll exit. And then this function again should return 0, which I never did, but that shouldn't matter. And maybe that was the problem. It does seem to work more robustly now. I'm going to remove these sleeps again and put back the thread priority that we had. I don't think that matters still. But I just want to set the code up how I initially had it and show that it hopefully seems to work. Because this should work if I understand this at all correctly. I shouldn't need that. This should work. That just worked. Yeah, I'm aware. I totally agree that putting guards around those critical sections is definitely something I want to do in this code. But for now, this seems to work. So I wonder actually if terminate thread is what was doing this. If terminate thread caused some kind of error that wouldn't allow us to create threads later. Maybe that's the problem. Again, I really don't know. But this at least seems to be working. So I'll run it 6 more times because I just ran it 4 times. 7, 8, 9, 10. This seems to be working pretty robustly. And again, I mean, like that's not enough for a robustness check for me to just run it 10 times. I need to test it a lot more than that. But the fact that it did work now when it never did before, and it works with like those extra critical sections not being used, or without those extra critical section calls, which I didn't think we should need, I think we fixed it. So there's a lot more testing I should do on this, but in any case, quick tests here prove that it at least works right now. And I'm going to do one final thing, and then I'm going to go. And that's, I want to see roughly how long this actually takes for like the whole thing. I'm actually just going to do a, also I'm going to clean up a little bit here. I want to do a git stash and then roughly measure this, which is not going to be very accurate, but so I'm just going to do, again, a git stash with this, and we should have the same parameters. This is still going to render the wave. And then I'm going to look at the trace. I mean, already, I feel like this noticeably takes longer. Let's look at the trace again. And we should see several. So this is around a millisecond for most of these. Here again, everything's serial. And we should see like 2 milliseconds for all these. More than 2, 2.9. Oops. 3 milliseconds. So 1.2, 1.1, 1.705, 2.505. Whereas if we git stash pop, and I'm also going to re-enable optimizations again. Where I do git checkout -p, and I make sure I'm very careful not to hit the wrong keys. We do want to discard that hunk and nothing else. And I run this again. We should see on average this is faster. And then it didn't work. Ah, fuck. Okay, well, this is enough for tonight. I'll have to bang my head against this later, but at least thanks guys for hanging out. We proved that this works sometimes. What a pain in the ass. In any case, this is a proper approach. The code doesn't work yet, but we'll get there. Thanks guys for hanging out, and I will see you next time.